The universe is full of strange wonders and mysterious places, but few are as baffling as the vast void where almost nothing exists. NASA and astronomers have identified regions where matter is completely absent, creating awe-inspiring and terrifying emptiness. These cosmic voids raise profound questions. Why is there so little matter in these regions? How did they grow to such enormous sizes? For more than 30 years, scientists have studied these mysterious phenomena, but only recently have new ideas emerged that could change our understanding of the universe. This void, a vast expanse of space devoid of stars and galaxies, appears like a vast desert without stars. Instead of the light of countless galaxies, there is only darkness and emptiness. These anomalies stand in stark contrast to the rest of the universe, defying known laws of physics and challenging our understanding of cosmic evolution. Their sheer size is staggering, spanning millions of light-years and rivaling the largest known cosmic structures, such as the Virgo cluster or the Laniakea supercluster. A single light beam traveling at 300,000 kilometers per second would take thousands of years to pass through one of these vast voids. But despite their emptiness, these voids aren't completely barren. Researchers have found isolated galaxies within them, lonely specks of light floating in the darkness. The fact that these galaxies exist in these desert regions only deepens the mystery of how these voids came to be. One of the most famous examples is the Booth void, discovered by astronomer Robert Kirchner in 1981. Stretching across 330 million light-years, it earned the nickname the Great Nothing. At the time of its discovery, it was considered a unique anomaly. Since then, much larger voids have been discovered, such as the Eridanus void, which is over 500 million light-years across. Such gigantic voids are not uncommon. There are thousands of them, and together they form an important part of the universe. When we think of the voids of space, we naturally think of dark matter and dark energy, the mysterious forces that shape the universe. Could these voids have something to do with these mysterious phenomena? Some theories suggest that the size and distribution of the voids could reveal important clues about the nature of dark energy, which is thought to be driving the universe's accelerating expansion. The void may appear empty, but it can still contain invisible forms of matter, such as dark matter, which does not emit or reflect light. These hidden forces may be more common in the void than in other parts of the universe, making them essential to understanding the universe. To visualize the scale of the void, imagine the universe as a football field. Clusters of galaxies would appear as small patches of the field, and the void would dominate the rest of space. Scientists estimate that only 10 to 20% of the universe's mass exists in visible structures, with the rest in the vast void. By studying these voids, scientists can study the effects of gravity and dark energy in regions where visible matter is minimal. By observing the light from galaxies within or beyond these voids, astronomers can measure gravity and infer the properties of dark matter. This research also helps us understand the geometry and evolution of the voids, shedding light on the mysterious forces that shape the universe. If Earth were inside one of these voids, our view of the universe would be completely different. In the 1920s, astronomer Edwin Hubble discovered that objects similar to the Andromeda Nebula were galaxies outside the Milky Way. This discovery expanded our understanding of the universe, which now contains about 2 trillion galaxies across 45 billion light-years in all directions. But if Earth were a vacuum, Hubble would never have seen another galaxy. He would have seen only darkness and concluded that the universe was a vast, sparsely populated void. It wasn't until the 1960s, with the advent of powerful telescopes, that humans were able to see far enough out to identify galaxies beyond that void. This thought experiment highlights how our perspective shapes our understanding. From our perspective, the universe appears to be filled with galaxies and stars, but the existence of these voids reminds us that what we consider normal may be the exception. The void challenges our assumptions and shows us that there is still much to learn about the true nature of the universe. The void also offers profound lessons about the nature of the cosmic fabric and our place in it. Galaxies and clusters make up the visible universe, but these regions are merely dense nodes in a much larger cosmic web, a vast network of filaments, walls, and voids. This cosmic web is formed by gravity, dark matter, and the initial conditions set during the Big Bang. The void, in particular, is the gap in this web where matter becomes unusually thin. It is like the space between soap bubbles, where the filaments of galaxies are thin walls. As the universe expands, these voids grow larger, pushing galaxies and matter deeper into the denser regions of the web. This process, driven by dark energy, is accelerating the expansion of the universe, and the voids are crucial for studying how this mysterious force works. But voids aren't just empty space. They're laboratories for studying extreme phenomena. Because these regions lack matter and gravity, researchers can test fundamental theories of physics, such as Einstein's general theory of relativity, under conditions that are very different from those found in dense galaxy clusters. For example, the distribution of galaxies around voids could help scientists understand how gravity works across vast distances, and could provide new clues about the fundamental structure of the universe. The isolation of void galaxies also raises curiosity. How did these galaxies form and survive in such a desolate environment? Some theories suggest they are relics of an earlier stage of cosmic evolution when matter was more evenly distributed. Others suggest that interactions with dark matter and energy could play a role in their unusual existence. Studying voids could also change our understanding of cosmic evolution. Early in the history of the universe, matter was more evenly distributed. Over billions of years, gravity magnified small differences in density, creating the massive structures we see today: clumps, filaments, and voids. By studying voids, scientists can trace this history and gain insight into how the universe went from a nearly uniform state to its current complex structure. One of the most exciting implications of studying voids is their potential to unlock the secrets of dark energy, a mysterious force that makes up about 68% of the universe and is driving its accelerating expansion. The growth and geometry of voids are directly influenced by dark energy, making them ideal tools for studying their properties. The future of void research looks promising. Modern telescopes like the James Webb Space Telescope, JWST, and the upcoming Euclid mission are poised to explore this region in unprecedented detail. With these instruments, astronomers will be able to map the voids more precisely, study their internal structure, and discover faint galaxies hidden deep within. Digging deeper into the mysteries of the void will help us answer some of the most important questions about the universe. What is dark matter and dark energy? How did the cosmic web form and evolve? And ultimately, what role does this vast void play in the grand history of the universe? In many ways, the void reminds us of the vastness and complexity of the universe. They challenge us to think beyond our immediate surroundings and consider the greater forces that shape our existence. This empty space, seemingly purposeless, holds the key to understanding the nature of reality. As our knowledge grows, the void can transform from a symbol of emptiness to a gateway to discovery, revealing the hidden structure of the universe. Being in this vast cosmic desert has the potential to not only transform our scientific understanding, but also reshape our philosophical and existential perspectives. Because without the void,